Hello, class. It's another beautiful day here in Hamilton, Ontario at the Inch Park. Uh, Today, I want to talk about spinning objects, specifically spinning a basketball. Around this time last year, I was going for my walk like I normally do with my basketball. And a couple approached me at the stop sign and they said, "How do you keep the ball spinning on your fingertips? How do you do it?" And I just blotted out the words. I said, "Practice, it's all about practice." But I got to thinking later on, why does the ball stay on the fingertips longer than it would if it wasn't spinning? So let's go ask some of our imaginary friends.
Okay, so now we are gonna talk to our friend Sully. Sully thinks that the reason why the basketball stays in its plane of rotation is because of Newton's first law of motion, which basically states that a body will remain at rest or in a state of uniform motion unless it is altered by an external force. An example of external force would be a physical push or for this case, friction. What Solly suggests is that inertia, which is the reluctancy to change the state of rest or uniform motion, is what is responsible. Now let's go over and talk to our friend Bill. Hello, Bill. How you doing? Bill thinks that gyroscopic force is responsible. All right. This force that imposes the tendency of a rotating object to maintain the orientation of its movement. This brings us to the idea of a gyroscope. Who can think of a way that gyroscopes are used? All right, Bill. Bill says, um, okay, Bill. Bill says that stabilizer bars in helicopters use the same principle. By having that tendency to rotate in the same plane of rotation, they're able to stabilize pilot cyclic input in helicopters, as well as when the helicopter tends to tilt. Okay, um, let's go over to Aaron and find out what Aaron has to say about this. Aaron thinks that centripetal acceleration is absolutely responsible. The acceleration experienced by a body while in uniform circular motion, this force points towards the center of rotation. It's kind of like an inwards gravitation. And that's what Aaron thinks. Let's go over to Sarah. Sarah has a really more wholesome all round perspective. She thinks that it is due to the law of conservation of angular momentum, which basically says that when no external torque acts on an object, no change of angular momentum will occur. A total angular momentum remains constant. So this is talking about torque and angular velocity. All right, now that we've heard all these ideas, I'm sure that Curious Joey's head is already spinning. I can see that from his eyes. But let's now go out and do some experiential learning. Let's go out there and see what spinning a ball actually looks like in real life. All right. When you see me spinning that ball, I just did something here. I'm gonna quickly pause and get back to it. So I spun the ball and then I switched the ball quickly. I moved from a relatively newer basketball, which would have a higher grip, but in this case, higher friction between the ball and my finger, to an older ball that is more used and has less thread and less friction. This will help to maintain that angular momentum. Let's watch this from the beginning one more time. All right. Something else that's curious to see is that when I spin the ball, if I just put my finger underneath the ball, it does the obvious thing. It falls from one side to another. But when I spin the ball, it tends to remain in that state of uniform angular movement. Um, This is also observed in such a way that if you notice what I did, I rotated the ball clockwise. That's another useful tip for you. I rotated the ball clockwise, which moved the ball from my thumb towards that pointing finger that is pointing upwards. By using an older ball and by putting the ball on my fingernail, I'm able to get the ball to spin for longer because that external force that Sully was talking about in this case is friction, and I'm able to significantly decrease the friction by using this technique. Um, the technique also affords me a sense of uniformity because the ball is spinning in one direction. If it was to spin towards my thumb and then I try to switch it over, that would be another form of external force. I know we're talking a lot about external forces and torques, but here we go. That's better. Let's do it again. Notice how I use my nail, the back of my fingertip, to keep the ball spinning. And you sort of have to follow the ball around because of the imperfection and the imbalance. So we need to keep following the ball's movement. All right, let's look at something slightly more down to earth. Let's look at the throw pillow, which I hope you're going to be doing with me. Just pick up a throw pillow from your living room and try to see if you can get it to spin. All right, I'm patting down the pillow so that the mass is evenly distributed across the pillow. And now I begin to spin. If you observe here, I'm going to use another pillow so you can kind of see how the dots are moving around. Something that's also very interesting here is that when you spin an object that has the shape of a square, it sort of looks like a circle. And that's also an interesting point. Now let's go over to something more risque. I don't know if you noticed that I flipped the plate upside down. Do you think that makes a difference in being able to maintain balance? It sure does. Now that's much better, isn't it? So if you can do it with a ball, you can do it with a throw pillow, and you can also do it with a book or a plate. Disclaimer here, no plates were broken or hurt in the production of this film. Now, this brings us to our challenge. What do I want you to do? I want you to go out there and practice your spin skills. So, I have three basic tips for you. It's a balancing act. As you can see, I kept moving my finger around to try to follow the ball. The next thing is speed helps. Don't be afraid of speed. In this case, speed is actually an advantageous part. The faster the object spins, the more it has that tendency to remain in its position. And last but not least, obviously, it's all about repetition, people. Repeat, repeat, repeat. Repeat, innovate, investigate, apply, repeat, repeat, repeat. And it's been a very fun week with you here, teaching you and learning from you. I'm really glad that we had this time together, and I'll see you next time. Have a great day. Bye bye.